so example 2 gets us into exponential and logarithmic form, and these are ideas. All right, so exponential form is the basic form of an exponential expression. The logarithmic form is a variation, it's a shifting of objects in an exponential expression to create a new type of expression called a logarithmic expression. You'll have log, that's saying it's a logarithmic expression, and notice BPN, all the same pieces are there, but they're in different places. All right, so what I want you to recognize is where things go and when you create the logarithmic expression. So here's how it works. The exponential expression equals some number. That's what we're going to take the log of. All right? Then the exponential expression is some base raised to some power. The base of the exponential expression becomes the base of the logarithm. Base, they're both bases. And the power is what the logarithm equals. Logarithms always equal powers, so the power always goes on that side of the equal sign. The base always is the base, and whatever this is what the exponential expression equaled. That's how we make logarithmic from exponential expression. Let me give you an exponential expression you know to be true. For example, would everybody agree that 2 to the 3rd power is equal to 8? If I make that into logarithmic form, log of 8 base 2 equals 3.
That's just the answer?
That's how you make logarithmic form. You rearrange it. So log of this number, that's the base, equals the power.
Seems simple.
Wherever these things are, again, looking back over here, whatever this equals is what we're taking the log of. The base of the power is the base of the logarithm, and the logarithm equals the power.
On the calculator, how do you get the smaller number? Like, what do you mean?
On your calculator, you can't.
I thought it was going to be easier.
No, on the calculator, there are 2 logarithms that you saw yesterday when we hit the second PRB, right, on our calculator, and right above PRB it says log, right? So just to remind you.
So is that just the ending?
Yeah, that's all we're doing is just modifying stuff right now. PRB, right? PRB, LOG. So your calculator has that button. To get to that, you have to hit the second key to get to it, right? So, and the screen that comes out has LOG and LN, all right? So on your calculator, LOG means log base 10. And LN means log base E. In any calculator you ever see in your life, those are the only 2 bases you ever get to work with on a calculator, base E and base 10. We will learn that every logarithm's base can be modified to anything you want it to be, so it doesn't matter that those are the only 2 on the calculator. We can modify things to make them base 10 or base E. That's down the road. All right, so keep in mind, calculator will be used in some places in this book, in this chapter specifically, but LOG is base 10, LN is base E. Those are the only 2 bases your calculator knows. All right, so going on to what they're asking us to do on example 2.
I feel like this is a video of the first one.
Well, we'll see. We're trying to write the logarithmic form of 3 to the 4th equals 81. Oh, let me go back one page real quick. I just remembered for something I forgot. I tend to speak proper mathematics. So when I'm reading this out, this statement here is read exactly like this. Log of n base b equals p. That's how you read a logarithm. Log of something base something equals the result. So that's how you read a logarithmic expression. All right. So if I look at example 2, what is the logarithmic form of 3 to the 4th equals 81? This is an exponential expression. And I want to change it into logarithmic form. So again, I write logarithmic form in this manner. I got log, and I got 3 boxes to fill. I've got, just use the same color. I got a number that goes here, a number that goes here, and a number that goes here. There's an equal sign. Okay. We take log of the result. The base of the exponential expression is the base of the logarithm, and the power is what the logarithm equals. That's how we make logarithmic form out of exponential form. That is a necessary skill to to be able to deal with logarithms. You need to be able to do that very easily, recognize where everything goes, be able to write it out like that anytime you feel like it.
So log of n plus
Log of 81 base 3 equals 4 is the logarithmic version of 3 to the 4th equals 81. Okay. Again, this was invented by a guy. That's what he decided everything, that's where he decided everything goes. So we just make sure we put everything where it belongs. We'll learn how to work with these and be able to modify from one form to the other whenever we need to. Because sometimes logarithmic form is better to work with, sometimes exponential form is better to work with. We have to have the capacity to very easily switch from one to the other. Okay, exponential form of log of 1,000 base 10 equals 3. So exponential form, this is logarithmic form here, right? Logarithmic form. And we're trying to get exponential form. Exponential form is some number raised to some power equals some number, right? So when I look at a logarithmic form, the base of the logarithm and the log equals the power. The base and the power are sitting there staring me right in the face. Log of 1,000 base 10. 10 is the base. It actually, when you read it out, log of 1,000 base 10 is saying 10 is the base, right? And the logarithm always equals the power, so the base is 10 and the power is 3. The only other place left over here is there, so that's where 1,000 goes. So again, if you read it properly, log of number base number equals number. The base is the base, the power is what the log equals, and the other number goes on the other side of the equal sign. That's how we change from logarithmic into exponential form. All right, so that's what I want you to be able to do today. I want you to be able to change from logarithmic to exponential. If it asks you for an inverse relationship, this is the inverse relationship of that and vice versa. So if they give you this and say write the inverse, write the logarithm. If they give you a logarithm and say, or an exponential, say write the inverse, write the logarithm. Okay, so just that's what you're doing there. All right, so there's a section like that. And other than that, there's solving equations. They'll be like these where you can make the bases the same number. It won't be like this where you'd have to use some magic tricks of math in order to figure it out. And the magic tricks of math, again, I'm going to teach you when we get there. They're not hard to do, it's just you need to know how to do them. So we'll learn that at some point.